Hello students, today we will learn about gear trains. So what are gear train? Gear train is a set or system of gears which are arranged to transfer rotational torque from one part of mechanical system to another. So a gear train is a set or system of gears arranged to transfer rotational torque from one part of a mechanical system to another. So here we can see in a figure that there are 4 gears which are arranged one after the other. So it is a set or system of gears which are arranged to transfer rotational torque. So here you can see this gear is rotating in this direction, this one is rotating in this direction, the other one is rotating in the opposite direction to the second one, and you can see fourth gear is rotating in opposite direction to the third gear. So in this way the gears are arranged one after the other to transfer rotational torque from one mechanical system to another. So this set of gears can transfer rotational torque from this mechanical system to some other mechanical system. So gear trains consist of driving gears, intermediate or idler gears, and transfer gears. So the gear trains consist of driving gears which are driving the systems, then intermediate gears which come in between two gears, or idler gears which are just present there, that is they are ideal gears, they do not do any function but yet they are required, and transfer gears. So driving gear is where the energy is input into the system of gears. So the driving gears are where the energy is input into the system of gears. So energy is sent to the driving gear from which it is transferred to the other gears. Okay. Then the intermediate gears transfer that torque and may reduce or increase it according to the gear ratio involved. So the intermediate gears, what is the function of these intermediate gears? They will transfer the torque, and they may reduce or increase the torque according to the gear ratio. Okay, based on the gear ratio, it will either increase or it will reduce the torque, that is the intermediate gears. Then the transfer gears passes the modified torque onto the next component in the machine, whether it is a wheel, a winch, a counter, or any other thing that needs power. So what is the function of the transfer gear? The transfer gear will just pass. So as the name indicates, it will just transfer, or it will just pass the modified torque. Modified torque means the torque which is obtained from the intermediate gear on to the next component. So what is the next component? So the next component can be, so next component in the machine, which may be whether it is a wheel, so it can transfer the modified torque to the wheel or to the winds, or a counter, or any other thing that needs power. So this figure is showing us a simple gear train in which there is only one gear for each axis. So velocity ratio of pair of gears is inversely proportional to the diameters of their pitch circle, and the diameters of pitch circle equal to the number of teeth divided by the diameter pitch. So we will understand what it means when we write down the formula. So figure shows a simple gear train in which there is only one gear for each axis. Velocity ratio of a pair of gears is the inverse proportion of the diameter of their pitch circle. That is, velocity is inversely proportional to the diameters of pitch circle, or we can write as the diameters of pitch circle equals to the number of teeth divided by diametral pitch. So it is necessary for two mating gears to have same diameter pitch, so that to satisfy the condition of correct meshing. So if there are two teeth, so if this is one teeth, okay, and this is the other teeth, they are meshing with each other. So these two gears must have same diameter pitch, otherwise what happens is they will not have correct meshing. Okay, so to have correct meshing, they must have same diameter pitch. So it is necessary for two mating gears to have the same diametral pitch, so that to satisfy the condition of correct meshing. So we can say that, so if diametral pitch of two mating gears is same, we can say that, we can infer that the velocity ratio of the pair of gears is inversely proportional to their number of teeth. So thus we infer that the velocity ratio of a pair of gears is the inverse ratio of their number of teeth. Okay, for a simple gear train which is shown in this figure, what is the velocity ratio? So for a simple gear train shown in the figure, we know that velocity ratio is represented by omega 1 divided by omega 2. It is inversely proportional to number of teeth n2 divided by n1, and omega 2 divided by omega 3 is equals to n3 divided by n2. So you can see this is inversely proportional. So number of teeth are inversely proportional to, ratio of number of teeth is inversely proportional to the velocity ratio. Then next, so as we were discussing, for simple gear train which is shown in the figure, we write the velocity ratio omega 1 divided by omega 2 is equals to n2 divided by n1, which is inversely proportional to the number of tooth. Then omega 2 divided by omega 3 is equals to n3 divided by n2, and omega 3 divided by omega 4 is equals to n4 divided by n3. Now where n is representing the number of teeth. Okay, so we can combine these equations to give the velocity ratio of the first gear in the train to the last gear. So these equations can be combined to give the velocity ratio of first gear in the train to the last gear. Now, how do we write it? Omega 1 divided by 2 is equals to n2 n3, 1 divided by 4 is equals to n2 into n3 into n4 divided by n1 into n2 into n3. So we can write it as n4 divided by n1. So the number of tooth in the numerator are those of the driven gears. So these are tooth of the driven gears. The number of tooth in the numerator are those of the driven gears, and the tooth number in the denominator belong to the driver or driving gear. So here we can see that gear number 2 and 3 are both present in the numerator as well as the denominator. So here you can see here it is n2 and n3. Here also it is n2 and n3. So we can say that they are both driver and also driven. So gear 2 and 3 are both driver and in turn driven also. So they are called as idler gears. Idler gears. So these tooth numbers get cancelled. Okay, idler gears do not affect the magnitude of the input or output ratio, but they do change the direction of rotation. So idler gears, their tooth numbers get cancelled. Okay, since their tooth number get cancelled, idler gears do not affect the magnitude of the input or output ratio, but idler gears change the direction of rotation of change the direction of rotation. So here you can see the first gear is driving in anti-clockwise direction, the second gear in the clockwise direction, the third gear again in the anti-clockwise direction, the fourth gear in the clockwise direction. So the gear ratio depends on the size of the intermediate wheels, which are called as idlers or idler gears. So the gear ratio is independent of the size. So it does not depend on the size of the intermediate wheels, which are called idlers. So idler gears do not affect the gear ratio also. So for an odd number of externally geared wheels, the direction of rotation of the last wheel is same as that of the first wheel. So here the number of gears is even number, it is not odd number. So you can see the first wheel is rotating in the anti-clockwise direction and the third wheel is also rotating in the anti-clockwise direction. So if we consider there are only 3 wheels in this gear train, then the first wheel and the last wheel, okay, it has odd number of wheels, that is 3 is an odd number. So the first wheel and the last wheel have same direction of rotation for odd number of wheels. So for an odd number of externally geared wheels, so it must not be internally geared, it must be externally geared wheels, the direction of rotation of the last wheel is the same as the first wheel. Then for an even number of wheels, the direction of rotation of the last wheel is opposite to that of the first wheel. So here we can see this is even number of wheels here, that is 4 is an even number. So the first wheel is rotating in anti-clockwise direction, whereas the last wheel is rotating in a clockwise direction. So for an even number of wheels, the direction of rotation of first wheel is opposite to that of last wheel. Okay. So one of the most common use of gear trains is the gearboxes of cars. So it is most commonly used in the gearbox of car. use of gear trains is in the gearbox of cars. So, in the simplest form of a crash gearbox, a collection of spur gears was arranged to give different ratios of input to output speed. So, in simplest form of crash gearbox. So, here a collection of spur gears was arranged to give different ratios of input to output speed. And in case of reverse gear, change the direction of the output rotation. In case of reverse gear, change the direction of the output rotation. Now, what are the applications of these gear trains? So, there are many applications of gear trains. So, they are used in mechanisms. Then, they are used in automotive transmissions. And these gear trains are used in differential gear mechanisms. So, basic differential gear mechanisms, and they are used in planetary gear speed reducer mechanism, planetary gear speed reducer mechanism, and they are used in factory automation. Then they are used in packaging machines. They are used in industrial robots. They are used in food processing machines. They are used in car production machines. Then machine tool industries also use gear trains. Then in material handling also gear trains are used. Then in printing machines. So here you can see how the gears are arranged in the printer. Okay. So from this figure, see, these are all the gears: 1, 2, 3, 4, 5, 6, 7 and 8. So many gears are arranged in a printing machine. So from one portion to the other portion, that is from one gear to the other gear, the motion is transferred. So in this way, these gears are helping for running various type of machines when they are arranged accordingly. Then automobile or automotive, so automatic cutting, and in welding machines also gear trains are used. Automatic cutting and welding machines. Then machine for medical and cosmetic fields. Machine for medical and cosmetic field also requires gear train arrangement in them. Then for construction machines also, so to run this machine also there is requirement of gear trains. Then wood and glass processing machines, and then they are also used in agricultural machinery. So there are so many applications of these gear trains. So here I will show you how the gears are arranged in the clock. So from this figure we can see this is a clock and how the gears are arranged. So even a pendulum can be arranged. So here there is a pendulum here. There is an escape wheel. There is a pallet. There is an anchor. Okay, you can see there is a barrel here. Okay, so this is the main wheel. So this which is shown here is the main wheel. Then this is the driving weight which is linked to this main wheel. So you can see how the main wheel is connected to different gears here. So how these gears are helping to run the, so this is the second hand, this is the minute hand which is connected to this gear wheel, and this is the hour hand. So in our domestic machinery, that is clock, how the simple gear trains are arranged and how they become useful for running the clocks is shown in this figure. So I hope you have understood the topic of gear trains. Thank you.